Hi there and welcome. It's Matrix Uploaded. It's time for Physical Sciences today. My name is Tinyiko Kosa and we are actually continuing even today talking about how do we describe motion. So it's all about description of motion. I think for this lesson and the coming lesson again, we'll still be talking about how do we describe motion. Now, earlier on, we introduced terminologies or quantities that we use to describe motion. We said time becomes important, position becomes important, the speed becomes important as well. We've looked at that. We looked at velocity. We looked at displacement. Okay, all these things. Now, we also introduced the fact that when we talk of these physical quantities, some of them are scalar quantities. Those that we can only talk about how big they are, but they've got no direction. We can't tell the direction in which the motion is moving. But there are also those quantities that are vector quantities. And these ones are quantities that have got both magnitude and direction. So we should always, and this is very important, when we deal with those quantities like velocity, displacement, so far that we have introduced. When you talk of those, you must always know that you have to tell the direction that is required there. Because without the direction, you have actually lost it. It is not displacement anymore, it could be distance. It is not velocity anymore, it could be speed. So be sure that you show direction. Now, the motion we're dealing with, I pointed out in the previous lesson that we're dealing with motion in one dimension. So we're looking at motion where either something is moving forward or backwards, up or down. Okay? Now, in these cases, we can actually easily use mathematical science to show direction. We can say, for example, the direction the forward direction, let it be positive. In that case, it would mean the reverse direction or the backward direction would be negative. Okay? And that will be consistent with the Cartesian plane. We'll have negative y-axis and positive y-axis, negative x-axis and positive x-axis. That's fine. Now, we can also use the cardinal points to show direction. We can have the north and south. We can have the east and west in that way. And because we're talking about motion in a straight line, okay, west or east, north or south, okay, up or down, forward or backwards, okay, to the right or to the left, those kind of things. So direction becomes important. But one other quantity that I want to introduce to you today, and now, it's a quantity called acceleration. Okay? Now, what is acceleration? Acceleration is the rate of change of velocity. The word rate comes back again. Now, when we talk rate, we're talking about something changing per time. Okay? So when we say acceleration is change in velocity over time, it would mean that we're looking at at velocity changing and looking at how long it takes for that object to change its velocity. Whether it changes its velocity by increasing it or decreasing it, it doesn't matter. The fact is that it has changed velocity and therefore we have some acceleration happening there. Let's just quickly look at this. So by virtue of what we have been speaking about, we would then know that velocity or change in velocity divided by change in time would be acceleration. And if there is change in velocity, we therefore have situation where we observed an object moving at some initial velocity, and it moved during that motion, it changed its initial velocity to some final velocity. And that change there took place over a period of time. Okay? Over a period of time. So that is the time there. So when we do that, you would see that we would have the situation. So delta V over delta T there becomes, if you like, V final minus V initial for us to get that change, that delta V. okay, divided by delta t. Now, you would recall that velocity is measured in meters per second. Time is measured in seconds. So if we've got meters per second divided by second, we'll end up with meters per second, or meters per square second. And this is the unit of measurement for acceleration. So when we talk acceleration, units of measurement, meters per square second. Okay, so that's how we work out acceleration, and those are the units in which we measure it. Again, know that this is a vector quantity. It has got direction. See you in the next section.